Okay, I'm noticing as I look in the book that they're giving you examples that you can't really graph the way that I showed you. You have to use a calculator. Still want you to be able to graph the way that I showed you, finding the zeros and the local minimum and maximum. On the example that I showed you, there was only one local minimum and one local maximum. There could be more than that. The reason that there was only one local minimum and one local maximum is because it had a degree of 3. If it had a degree of 7 and it's going to change direction 7 times, something like this, then you would have a local maximum here, 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 and a local minimum here, here, and here. So it doesn't have to just be 1 and 1, okay? Even though this one's higher than the other two, we would still identify all of them. So I'm going to show you how to do it on the calculator. If you're trying to graph it on the calculator, you're just going to type it into the y equals. So I'm going to go in and I'm going to do one that tells me in the book to graph it using the calculator. It tells me x to the 4th minus 4x to the 3rd plus 3x plus 5. And then I'm going to go to my graph. My window is obviously too zoomed in, so I'm going to zoom out. What we're really looking for here is where it's continuing to infinity and continuing to infinity. So I have a degree of 4, which is positive. Sorry, I have a degree of 4, which is even, and it has a positive value because it's 1. So I know that that means that it's continuing to infinity in this direction and this direction, which is happening right here and right here. So I can see the entire thing now, except for this bottom minimum value. So I'm going to change my y value a little bit. So I'm actually going to change my x's to be only from negative 3 to positive 5. So I'm going to go x from negative 3 to positive 5, and then my y values aren't low enough, so I'm going to increase my y value. So I'm going to go into the window. In the x values, I'm going to change to negative 3 and 5. The y value I'm going to change to negative 15. 10 is fine. And then look at the graph again. See, I can see that value that I couldn't see before. So now what I want to do is I want to calculate the local minimum and maximum. In order to do that, what you're going to do is you're going to go to the calculate, which is second trace. The minimum, we'll do minimums first. You need to make this little, I call it a spider, I don't know what it's called, this little thing to the left of the lowest point. So I'm going to go to the left of that and then move it to the right of that. So it tells you the right bound, the left bound, and the right bound. And then it says guess, and you say yes. So it's going to tell me that if I draw a picture of this graph right here, this is the graph that I have. It's telling me that this value right here is a y value of 4.05 approximately. Now I'm going to go on and I'm going to find this maximum value. So now I'm going to go back into the calculate. This time I'm going to calculate a maximum. I need to be to the left of that, which I am. And then I'm going to go to the right of it when it says right bound. Left bound, right bound means the left boundary and the right boundary. So I'm saying these are the boundaries for my graph. This is kind of hard to see, huh? I don't know how to make it better. Those are the boundaries of my graph, and then guess, and then it tells me the value that's the highest in between them. So it tells me the maximum height is at y equals approximately 6.08. Now I'm going to go for this value right here, this minimum. So I'm going to go back to minimum, calculate minimum. I don't know how to make this seeable. I'm going to the left of that part, which it's to the left of that part right now. Now it says right bound, I'm going to go to the right of that. I'm to the right of it. And then it says guess. And it tells me that that value is at negative 13.13. And it says that that's an exact value. It's also probably an approximation, but It told me it was an exact value, so that's what I'm going to put. So these are all all your y values. That's what you're looking for. You don't care about the x's when you're doing this, okay? And so these are both local minimums. And this is a local maximum. Think of it as peaks and valleys. So the valleys are minimums, the peaks are maximums. And that's what you're looking for on these guys.